Hi, good morning, good day, good evening, and good night. Welcome to my presentation, which is called Applying Systems Thinking to Frame and Explore a Test System for Product Verification, a case study in large defense projects. The agenda for my presentation is first to give you some introduction to verification and the company projects, and also the problem as I have defined it. We're going to look at the methods I've used in my research, the stakeholders I have identified for the system. We're going to look at the description of the system, both in the current state and the proposed future state, which leads us to the value-added processes that I see for the test system. And we have to look at the obstacles that needs to be overcome to be able to implement these proposed changes. And I have analyzed these proposed changes through different methods like CATWOE, Systemigram, and Causal loops to see what effect these changes will have on the system and the organization. And finally, a conclusion. First, some background information regarding verification. The project management body of knowledge defines verification as the evaluation of whether or not a product, service, or system complies with a regulation, requirement, specification, or imposed condition. And as you see here, the V model, where verification is an important step, and it's not just a one-time effort, it's an iterative process looping through as many times as necessary. And verification is also considered in other steps in the model, like the requirements phase and the design phase, where you have to think about how will I verify my system. So verification is an important part of the V model and the systems engineering process. Kongsberg Defence and Aerospace has run three major projects. First, the Penguin project from 61 to 90. Then the Naval Strike Missile Development project from 96 till 2009. And last, the Joint Strike Missile Development project from 2008 to 2021. And as you can see from the pictures on the right-hand side, the last two are quite similar, while the first one is quite different. So we have been able to reuse more from previous projects on our later projects. Moving over to the problem definition. The problem with the test system we have today in the company is the low efficiency. And this is due to manual test execution, manual notification of new test results, and manual test result analysis. There's a lot of manual processes going on, tedious, time-consuming processes. And as I see it, we have future demands which will require us to run more projects in parallel and run the projects faster, which will make this problem even bigger. To give you some numbers on the problem, I have collected data from a hectic test period we've been through, where we were able to run 8 to 10 manual tests per day, working for 8 hours, 6 days a week. And we were able to put in some extra time, working for 4 extra hours, 4 days a week, running 3 to 4 additional manual tests. And comparing this to a theoretical automated test regime where we would be able to run up to 200 tests per day with the test arenas running 24 hours a day, 7 days a week, we see there's a huge difference. When it comes to the analysis part, we were able to run 7 to 8 manual test result analysis per day. And again, compared to a theoretical automated test regime, we would be able to analyze all the 200 tests. And this leaves us with a ratio of 1 to 15 for manual versus automatic operations. Of course, this is highly theoretical, so the truth probably lies somewhere in between, but as we see, there's a huge potential to increase the efficiency in our test system by going from manual operations to more automated operations. The methods I've used in this research is within the systems engineering domain. I started out with defining the problem, then I identified the stakeholders of the system, and then I used several systems thinking approaches, like drawing a stakeholder interest map to see the relationships between the system and the stakeholders. Then I defined the value-added processes that would increase value to the test system. And I used the CATWOE method to communicate with stakeholders and reflect on their feedback being in conflict or not. I used the Systemigram tool to see how the proposed changes would affect the test system and the organization. And I used the causal loop diagrams to see to what extent the proposed changes would affect the system. So the stakeholders I have identified for the test system are, of course, the testers who are running the tests, the system owners who want their system to be tested and verified, and are also often the analyzers of the test results based on the test executions. We have the project managers who want their projects to succeed. We have the company that wants their projects and products to succeed. The customers buying the products, the government sponsoring the projects, and the suppliers supplying the test system with their hardware. Here we can see the stakeholder interest map showing the relation between the system, the subsystems, and the stakeholders. For instance, the testers, they're interested in the simulation part of the system, and they connect to the company they work in. The system owners, they're interested in the analysis part of the system and are also related to the company they work in. While the suppliers, they're interested in the whole test system, supplying multiple subsystems, and they relate to also the company as well as the government. So there's a lot of relationships here. It's a complex situation, but it's a nice overview to see all the interactions going on. Now let's take a look at the current test system that we have in the company today. The first step is data preparation, where people prepare static data like map data and target data for later usage in the mission planning process, where people are preparing more type of dynamic mission data. And these missions are scheduled for simulation, where testers are running scenarios in test arenas. And finally, the test results are analyzed by analyzers, domain experts in different areas. And all these data are stored in different storage systems for later retrieval. The proposed changes that I want to make to our test system is to remove manual operations where suitable. And it's not suitable to remove all manual operations. It's typical that routine tasks could be done much more efficiently automating the processes, while more evaluating type of tasks is better performed by humans. So the processes of data preparation and mission planning, I recommend still to be manual operations, while the processes of simulation and analysis, which are more routine type of work, where people sit in test arenas pushing buttons to run the tests, and people later look through huge amount of data, finding specific information and comparing that to defined acceptance criteria to see if the test is okay or not. These processes could easily be automated, and I think it would increase the efficiency significantly. As we saw earlier in the problem definition, this could give us a ratio of up to 15 times higher efficiency. The value-added processes that I foresee for the test system are, as I have already talked about, automation of the test execution part and automation of the test result analysis part. In addition, I want to introduce machine learning to change the focus from everything to manage the exceptions. By letting machine learning algorithms alert about suspicious behavior so that analyzers can check issues that needs to be checked and not everything. I also want to test both the core and the adaptation part of the system for modularity in the way that we in future projects can reuse the core part of the system, which is then already verified. And I want to reuse test input over different test arenas and over different systems, subsystems, components to reduce the workload, prevent unnecessary tasks, and free time for other more relevant and necessary tasks. There are, of course, obstacles that we need to overcome to be able to implement these proposed changes to our test system, like lack of resources, people, time and money, which is always an issue, and lack of domain knowledge, like introducing machine learning, I think will require people attending courses, requiring internal training, which will take time. There's also lack of willingness to introduce risk for managers. Typically, project managers, they have the focus of ensuring success for their project and not necessarily for products in the long run. So we have to change their focus from project to product, which I think will require involvement from top management to give guidelines and instructions to the project managers for us to be able to implement these desired changes, which will hurt the projects to some extent. Moving over to the analysis part, starting with the CATWOE method, which I've mostly used for communicating with the different stakeholders. And I want to show you a couple of examples here with the most relevant stakeholders being the tester and the project manager, and see the system in different aspects from their point of view. So the tester sees the project manager as the customer. The actors of the system are software developers, scenario data providers, testers, and analyzers. The transformation going on is that the system provides test results based on scenario data and analysis of test results based on log files. The worldview is a simulation of test scenario. The owner is the project and the environment is the test stations. Compared to the CATWOE of the project manager, we can see the resemblance here. The project manager sees the Norwegian Armed Forces as the customer. The actors of the system are the system owners and the testers. The transformation going on is that the system provides test results based on requirements and verification plans. The worldview is verification of the product. The owner is the company, and the environment is the test lab. So these two main stakeholders agree. They want the same thing out of the system. It's just that they see things from different points of view. They have different abstraction levels. So in that sense, we're okay. But a challenge with the different points of view is that the project manager might not see things the way the tester does, in the way of how much today's system hurts in using, how much changes are really needed. So the project manager probably needs some convincing to see things the way the tester does, to make him understand how much these changes are needed and wanted. Here we can see a systemigram of the current test system, where we have the main line going from the upper left to the lower right, which are the necessary steps to get from the start to the end. Starting with a test system comprised of a structure containing data preparation system, mission planning system, simulators, data analysis system, and storage system. This structure provides scenario data to the tester, who runs the test scenario to generate the test results to the analyzer, who performs the test result analysis to achieve a verified product. And we have supporting operations to this main line, like the structure storing test descriptions created from scenario data to document the test scenarios. Also, the structure stores test results, and it stores test reports created from the test result analysis to document the verified product. In addition to these, we also have sort of optional operations going on, like data from tests, the test results, and data from analysis contribute to a knowledge base, which is used to trigger potential demands to update scenario data where previous scenarios did not trigger what was necessary. And it could also lead to inform the company to request software or hardware developers, suppliers to develop and supply new hardware and software to update our structure so that we will be able to do things that we couldn't do before. Looking at the proposed changes and how that will affect this test system, we see that there's really not much change. What's changed is that I have removed the tester and the analyzer from the main line, making this main line go much faster. The tester and then analyzer have now taken a more type of observer role, where they can look at what's going on, they can be informed, alerted about whatever they want, but they're still part of the system. So the company doesn't need to hire any more people. It doesn't need to reduce the amount of people. It's just that some take other roles, and other roles could be to optimize algorithms and other types of tasks. It could be new development, more work that are really much more engineering type of work. So I think it will be good for all parts. The testers and analyzers will get more interesting type of work, and the test system will run much more effectively. Then we look at the causal loop diagrams to see the extent of effects on the proposed changes. First, for the test execution part, we have the current system with a reinforcing loop by test results, giving more test data, giving higher test maturity, balanced by the test structure, its available simulators, and available testers, and how long it takes to run different tests. For the proposed system, I remove the tester, weakening this balancing loop at least by a factor of 3, since the testers are usually working 8 hours a day, while the automated process could run for 24 hours. But there will be a higher increase in efficiency because the testers are not that efficient. They cannot sit for 8 hours running tests. They have a lot of other type of work to do as well. So the efficiency will be, I think, higher than 3 times what it is today, and up to, as we saw earlier, 15 times higher efficiency, somewhere in between there. Looking at the causal loop diagrams for the analysis part of our current test system, we see that more test analysis give us more test reports, which increases the verification level. This is balanced by the analysis structure, limited by the time to do the analysis, which is highly dependent on the analyzers. So for the proposed analysis system, I seek to remove the analyzer, weakening the balancing loop. It's hard to put numbers on how much this will increase efficiency. But the goal is to be able to cope with the amount of available test result data so that the analysis part will no longer be the main bottleneck of the test system. Because it's proven to be the main bottleneck in our current test system. So this is the main problem and the most important thing to change, to be able to make this analysis part more efficient. Finally, we have a causal loop diagram for the machine learning part. Our current test system does not have machine learning, but the proposed system hopefully will introduce machine learning, which will reinforce machine learning by alerting analyzers about suspicious behavior, leading to updated algorithms. This is balanced by the analysis structure, dependent on the analysis time, and again dependent on the analyzers. So this will reintroduce the analyzers to some extent, but not like before. The machine learning will change the focus from everything to managing the exceptions. So the analyzers will be able to cope with the workload. So to sum up, I have in this research used systems thinking approaches to explore the problem and effects of the proposed changes. The main problem is that manual operations have proven to be bottlenecks in our test system. And this will be in conflict with future demands, so we have to do something about our test system to be able to cope with these future demands to run projects effectively in the future. I've analyzed the proposed changes and see how that will increase the efficiency of our test system by using the CATWOE method to communicate with stakeholders and see what they want out of the system, and if my proposed changes are in conflict with how they see things, which they are not, so I'm okay with that. We're moving forward with the proposed changes, using the Systemigram to visualize the impact. And that shows that it's really not much impact on the organization, just that people take different roles and the test system can run much more effectively. And the causal loop diagrams showed, at least to some extent, how much these effects will impact our system. Like the efficiency will increase to somewhere between 3 and 15 times the way things are done today. And finally, I would say that I really recommend to implement these proposed changes of automating the test execution part, automating the test result analysis part, and introduce machine learning to change the focus from everything to managing the exceptions. I see these 3 proposed changes as leverage points to the test system, which means that they are things that could dramatically change the system and the efficiency of the system. That concludes my presentation. Thank you for listening. And do not hesitate to ask me questions.